going to talk about how we can directly calculate the allele frequencies for a particular set of alleles. So let's say that straight hair and curly hair alleles show an incomplete dominant phenotype. That means that if you have either straight hair or curly hair in the homozygous state, you will have one or the other. So 2 copies of the straight hair allele gives you straight hair, 2 copies of curly hair gives you curly hair. If you are wavy-haired, you are the heterozygote. So there we see our intermediate phenotype. Now, in order to calculate our allele frequencies, we need to first calculate the total number of alleles in the population. So our total alleles is going to be based off of the number of individuals in our population. Now, keep in mind that every individual has 2 versions of each allele. Now, they might be the same or they might be different, but each individual carries 2 alleles for the hair phenotype. So if we have 125 individuals, our total alleles in the population is going to be 125 plus 125 for 250 total alleles. Let's first start by calculating the allele frequency for the straight-haired allele. Let's label that as P. Because this is incomplete dominance, it doesn't really matter which we label what. And let's label the curly-haired allele Q. So let's start by calculating P. So the frequency of the P allele is going to be equal to the number of straight-haired alleles divided by the number of total alleles. If we look at the number of straight-haired alleles, we see that there are 35 people that have the straight-haired phenotype. Each of them have 2 copies of the straight-haired allele. So 38 plus 38. Now we can't forget these wavy-haired people, because those wavy-haired people also have a copy of the straight-haired allele. They just have 1 copy of a straight hair and 1 copy of a curly hair. So now we have another 62 alleles that code for straight hair. That's going to be on top of 250 total alleles. So our p-value, or the frequency of straight-haired alleles, is equal to 138 divided by 250, or 0.55. Now, if you give me just a second to erase this, we'll calculate the Q alleles. So P is equal to 0.55. Now let's work on Q. Q is equal to the number of curly alleles divided by the total number of alleles. So our curly alleles, we're going to start with those 25 people who are curly haired. Each of them have 2 copies of the curly allele. So 25 plus 25. And then remember that those people with the wavy hair also have 1 copy each because they are heterozygote. So we have to add in those 62 alleles. Divide that by 250 total. Q is the frequency of curly alleles. Excuse me. Which is equal to 112 over 250, or 0.45. So if P is equal to 0.55, that's our straight allele, and Q is equal to 0.45, that's our curly allele, we can then use this to calculate our genotype frequencies using our Hardy-Weinberg equation, p squared plus 2pq plus q squared. Now I did that quite a bit in other videos, so I'm not going to do that here. The other thing we could have done is once we calculated that p-value, oops, I did that backwards. We could have used that to calculate q. Q equals 1 minus p. And you can do it either way. I wanted to go through and show you how to directly calculate just so you know, but you can skip that step of calculating the Q and just calculate it directly from P.